Good morning, ma'am. Myself, I Vasundhara from 2nd CSC. My presentation is about state and prove the Euler's formula for planar graph. Outline of this presentation is to introduce the Euler's formula, definition of key terms, understanding the components, historical content, visualizing Euler's formula, proof of Euler's formula, inductive step, case analysis, significance and application, conclusion of the proof. Firstly, we will discuss about introduction to Euler's formula. Euler's formula is a fundamental theorem in a graph theory. It states the relationship between the number of vertices, edges and faces in a planar graph. The formula is given as V minus E plus F is equals to 2, where V is vertices, E is edges, F is faces. Euler's formula for graph. If G is a connected plane graph with V vertices, E edges and F faces, then V minus E plus F is equals to 2. Example. These are the two examples of Euler's formula. Definition of key terms. A planar graph is a graph that can be drawn on the plane without any edges crossing. Vertices V are the points where edges meet in the graph. Faces F are the regions bounded by edges including the outer infinite region. Planar graph definition. A planar graph is a graph that can be drawn in the plane without crossing, that no two edges intersect geometrically except at the vertices to which both are incident. Any such drawing is called plane drawing. These are two figures. First one is a plane graph, second one is a plane drawing. Understanding the components. The number of vertices V represents the distinct point in graph. The edges E are the connections between these vertices. Faces F includes all closed areas created by edges, counting the outer area as well. Graph is a pair V, E of two sets where V equals to set of elements called vertices. E is equals to set of pair of vertices called edges. Example, G is equals to V, E, where V is equals to contains V 1, 2, 3, 4, E is equals to 1, 2, 1, 3, 2, 3, 3, 4. Notation. We write G is equals to V, E for a graph with vertex set V and edges set E. V of G is the vertex set of G and E of G is the edge set of G. Historical context. The formula was first conjectured by the Swiss mathematician Lorenhard Euler in 1758. Euler's work laid the foundation by topology and graph theory. The proof of this formula has been pivotal in understanding planar graphs. Visualizing Euler's formula. A simple example can illustrate the formula using a triangle which has three vertices, three edges and two faces. The calculation gives us 3 minus 3 plus 2 is equals to 2. Aligning with Euler's formula. Visualizing representation helps in grasping the relationship outlined by the formula. Example for Euler's formula. How many vertices, faces and edges an octal pyramid has? In octal pyramid, number of vertices is equals to 8 plus 1 is equals to 9. Number of faces, 8 plus 1 is equals to 9. Number of edges, vertices plus faces minus edges is equals to 2. 9 plus 9 minus E is equals to 2. Number of edges is equals to 16. Proof of Euler's formula. V being with a simple planar graph containing a single vertex. Vertex is equals to 1, edges is equals to 0, faces is equals to 1. This satisfies Euler's formula as 1 minus 0 plus 1 is equals to 2. This base case establishes a foundation for introduction. Euler's formula V minus E plus F is equals to 2 holds for all connected planar graphs. What if a graph is not connected? Suppose a planar graph has two components. What is the value of V minus E plus F? Now, what if it has k components? Prove that the Pestrine graph is not planar. Inductive step. Assume Euler's formula holds for all planar graphs with k edges. We will show it holds for a planar graph with k plus 1 edges by adding an edge. The addition of an edge either connects two existing vertices or creates a new face. Case analysis of Euler's formula. If a new edge connects two vertices, it increases the face count by 1. If it creates a new vertex, both the vertex and edge counts increases, maintaining the formula. In both scenarios, the relationship V minus E plus F is equals to 2 holds true. Significance and applications of Euler's formula. Euler's formula is essential in various fields including computer science and topology. It aids in graph coloring, network design and geographical mapping. Understanding this relationship enriches our knowledge of planar structure and their properties. Conclusion of the proof. By the principle of mathematical induction, the formula holds for all planar graphs. This confirms the validity of Euler's formula V minus E plus F is equals to 2. The proof highlights the elegant relationship between vertices, edges and faces. Principle of strong mathematical induction. Let P of n be a statement defined for integers n, a and b be fixed integers with a less than or equals to b. Suppose the following statements are true. Then P of n is true for all integers n greater than or equals to a. Thank you for giving this opportunity.